We're moving from design into production reality. For a regulated blockchain platform, readiness means more than getting deployed. It means automated pipelines, secure infrastructure, release control, monitoring, and incident response working together before digital assets go live. At this point, the design foundation is in place. Architecture, platforms, tokens, settlement, custody, compliance, security, and integration. The focus now shifts to production readiness, deploying safely, monitoring continuously, governing change, and operating with enterprise-grade reliability. Production readiness is a mindset, not just a deployment milestone. For blockchain platforms that handle tokenized securities or stablecoin settlement, the real question is not, does the code run? It is, can the entire operating system be trusted under real conditions? That includes performance, security, custody, compliance, monitoring, incident response, and governance. Smart contracts, nodes, off-chain services, integrations, and workflows all need to be validated together. Before launch, define measurable readiness gates that audit, risk, and executive stakeholders can confidently approve. A strong environment strategy adds control as delivery moves closer to production. Local development supports speed using local chains, mock services, and synthetic wallets. Testnets and integration environments prove smart contract behavior, APIs, custody flows, and transactions with safer data. Staging should look and operate like production, including permissions, monitoring, and release procedures. Production then applies the strictest gates: approved deployments, protected keys, monitored nodes, incident support, and clear ownership. Test environments for regulated platforms need to be realistic without creating unnecessary risk. Use synthetic or masked investor identities, issuer records, wallet addresses, and compliance states. Keep controlled test wallets, mock custody accounts, and test stablecoins so transactions are repeatable. At the same time, staging should mirror production APIs, roles, nodes, monitoring, and security policies. Define retention, refresh, anonymization, and access rules so confidential data stays protected while deployment behavior remains predictable. Deployment strategy depends on the trust model. On public mainnet, the priority is release discipline, gas planning, verified contracts, hardened keys, and monitoring, because mistakes are visible and difficult to reverse. Permission networks shift more effort toward member onboarding, access control, and coordinated release windows. Consortiums add multi-party approvals and compatibility management. Hybrid models are the most complex, because public settlement, private compliance, and enterprise integration all have to work as one operational system. A blockchain CI/CD pipeline should treat smart contracts and supporting services as one release system. Every commit triggers compilation, tests, static analysis, security scans, container builds, and deployment simulations. Artifacts are versioned, so the exact code can be promoted or rolled back. Automation provides speed, but governance controls risk. Approvals protect staging and production. Audit logs preserve evidence, and segregation of duties prevents one person from building, approving, and releasing critical contract changes. Think of cloud deployment as the path from code to running services. Terraform defines networks, clusters, databases, secrets, and monitoring in version-controlled templates, making environments repeatable and auditable. Docker packages APIs, indexers, adapters, and workers with their dependencies. Kubernetes runs those containers with scaling, health checks, rollout strategies, and recovery. The important point is alignment. Networking, encryption, identity, logs, and regional availability all need to match enterprise security and reliability requirements. Secrets should be handled as production assets, not ordinary configuration values. Deployment keys, RPC tokens, custody credentials, and seed phrases belong in dedicated vaults or HSM-backed services with audit trails and rotation. Pipelines should receive only short-lived role-based access through workload identity, never hard-coded keys or loosely protected CI variables. Most importantly, separate the ability to deploy contracts from the ability to move funds or sign operational transactions. That separation limits the blast radius if automation fails or credentials are compromised. Smart contract deployment should be a controlled release, not a one-off transaction. Scripts need to capture every variable: constructor inputs, linked libraries, proxy initialization, role assignments, and verification commands. The same process should run in local, testnet, staging, and mainnet environments, producing records for addresses, bytecode hashes, ABI versions, transaction hashes, and configuration. Before production use, require review, security sign-off, approval, and smoke tests for permissions, pause states, transfer limits, and events. Rollback in blockchain systems is not a single action. Off-chain components, such as APIs, indexers, interfaces, and integrations, can often be reverted quickly. Smart contracts require a different playbook: controlled upgrade paths, time locks, governance approval, pause options, and audit evidence. Migration planning closes the loop by moving roles, permissions, metadata, and index data safely. Every release should define go or no-go criteria, validation checks, backout windows, and escalation paths before production changes begin. Observability turns blockchain operations into measurable signals instead of guesswork. Smart contracts, RPC providers, APIs, custody systems, databases, and compliance services all emit telemetry: logs, metrics, traces, and events. Prometheus collects metrics, while Grafana turns them into dashboards teams can act on. Security logs and alerts feed the ESIM for correlation and audit trails. The key is to define SLIs, such as confirmation time, API errors, node sync health, and indexing lag, then route breaches into incident response. Effective blockchain monitoring connects on-chain activity with the systems that observe it. Contract events show whether token actions and permissions are behaving correctly. RPC metrics reveal whether applications can reliably read data and submit transactions. Node health confirms that the network view is current and stable. The transaction lifecycle ties these signals together, from mempool submission through confirmation, finality, indexing, and reconciliation. Strong monitoring makes failures visible before users or auditors find them. When production incidents happen, teams need a practiced response, not improvisation. A dashboard detects symptoms such as failed transactions, node issues, settlement delays, or custody integration errors. The runbook turns that signal into action. During an RPC outage in a settlement window, for example, teams may pause risky queues, fail over providers, confirm asset safety, assess customer impact, and escalate by severity. If required, they notify regulators and preserve audit evidence. After recovery, the incident review strengthens monitoring, automation, and procedures. Production readiness is where architecture becomes an operating platform. It depends on controlled environments, repeatable CI/CD, managed infrastructure, governed smart contract releases, and deep observability across nodes, RPC, applications, and security events. Next, you'll package these trade-offs for executive decision-making and carry them into the final capstone architecture.